Hello, today we are going to learn about the ambiguous case of the sine law. The first thing which we need to keep in mind is that we'll be given two sides and one angle. And moreover, that angle is not the included angle, which means the angle is not the angle between the two sides. So let us look into different situations and figure out whether one triangle exists, no triangle exists, or two triangles can exist from this given information of two sides and one angle for a given triangle. Now let us say we have been given a triangle, and for that triangle we have been given angle A, the side opposite to angle A, which is side A, and this other side, which is the side B, opposite to the angle B. So in this triangle, if we have been given angle A and the two sides, so one of the side is the side which is opposite to the given angle, so we have to check for the ambiguous case. So the first scenario is that if the angle given is acute angle. Now the first thing we have to do is we should be finding the perpendicular height of this triangle and then compare the side A given with the calculated height. Now how do we figure out this height? Now this triangle is a right triangle, and using SOHCAHTOA we can write that sine A is equal to h over b. So h is going to be equal to b times sine A. So which means if we have to find out the height, we need to take the sine of the given angle and multiply it by the other side, not the side which is opposite to it, and we'll be able to figure out the height. And now we have to compare the side A with the height. Now suppose the side A is less than the height we have calculated using b sine A, which means there is no way that we'll be able to form the triangle because this side A will never be able to touch the base of the triangle. So in this case, we have no triangle existing. Let us consider that angle A is given to us as 42 degrees. This side B is given to us as 9 centimeter, and this side A given to us is 3 centimeters. So we've been given two sides and one angle which is not the included angle. Now what we'll first do is we'll find out the height. So height can be calculated as sine of the angle given, which is sine 42, and then that being multiplied with 9. So 9 times sine 42 is equal to 6.02. Now, when we compare the given side with our calculated height, we can see that the side A is less than our height, and so in this specific situation, there is no triangle existing. How about if the height and the opposite side, which is provided to the given angle, is the same? In that case, the height and the side are the same thing, so there's only one triangle existing, and that triangle will be a right triangle. Let us try giving the numbers to this situation and see how it goes. So let us say the side B given to us is 14 centimeter, angle A given to us is 30 degrees, and side A is 7 centimeter. So the very first thing is we'll calculate the height. So height is going to be the sine of the angle, which is sine 30, and that being multiplied by 14. So sine 30 multiplied by 14 is equal to 7. Now we can clearly see that the height and the side given the side which is opposite to the given angle, they are exactly the same. So it forms only one triangle, and that triangle is a right triangle. Let us now look at another situation where we figure out the height. So if our side A is longer than the height, then definitely A can be drawn easily, and hence we can definitely form a triangle. But there is one more thing which we need to clarify. So once the height is smaller than the side, which is A, then we need to compare the A and the B. So if A is longer than B also, then there is one triangle existing. But if A was shorter than B, then there are two triangles possible. So let us look into both the situations one by one. Now let us consider this angle given to us as 30 degrees, the side B given to us as 6 centimeter, and the side A given to us as 9 centimeters. So the very first thing is we'll find out the height. So the height is equal to sine of the angle, and that being multiplied by 6. So this gives us a height of 3. Now, because the given side is longer than the height, then definitely there is a triangle existing, but we need to see whether there's a possibility of one triangle or two triangles. For that, we'll compare the opposite side given to the angle with the other side. So because 9 is longer than 6, so there is only one possibility of the triangle. Now, why is it like that? In case if I want to move this side on the other side of the triangle, then definitely I'll be able to make the triangle over here. But in this case, the angle for the triangle is an obtuse angle, and we've been clearly given that the angle is the acute angle. The side A cannot be moved on the other side, and we cannot make a triangle from it. So this situation is not going to work over here. Now let us look into the last scenario where the height is smaller than this side, but at the same time the side A is smaller than the side B. In this case, there's a possibility of two triangles. So let us take the numbers and check it out. So if angle A given to us is 30 degrees, side B is 14 centimeters, and side A is 9 centimeters. So the very first thing is we are going to figure out the height. So height of the triangle will be the sine of the angle, and then that being multiplied by 14. So this gives us the height of 7 centimeter. Now we can clearly see if the height is 7, the opposite side to the angle is longer than the height. So the triangle can exist. But now what we can see is we can take this side A, we can move it to the other side. So you can see over here, the side A has been moved on to the other side. So there's a possibility of two triangles, because if this is 9, then this is also 9 centimeter. So one possibility of triangle is going to be triangle ABC, where angle B is acute, and the other possibility is the triangle A B prime or B dash C, where angle B prime is the obtuse angle. So in this case, we'll have to use the sine law, and we'll have to solve it for each of the two triangles. Now, what if the given angle is an obtuse angle? So we have taken all the conditions previously where the given angle was an acute angle. So if it is an obtuse angle, then the criteria is simple. So in the first situation, we've been given angle A, which is the obtuse angle. We've been given the side opposite to it, and then one more other side is given to us. Now over here, we just need to compare the side A and the side B. We don't even have to figure out the height. So if A is less than B, or if A is equal to B, then we cannot form a triangle out of it. But if A is longer than side B, then there is one triangle which can exist. So for the triangle where one of the angle given to us is an obtuse angle, there are only two simple situations from which we have to compare and see if there's a triangle existing or if it is not. I hope you understood the concept. See you in the next one. Bye-bye.